Hi, it's Helen Dakin and I'm back. This time I'm going to introduce you to the concept of amortization and amortization schedules. So with the next few lessons, we're going to be constructing amortization schedules. Let's begin with the first example. Example 1. A loan of $20,000 is to be amortized with quarterly payments over 1 year. The rate of interest on the loan is 10% compounded quarterly. You'll notice right away that we've got quarterly payments and a quarterly interest rate. So that's great because we know now that we have an ordinary simple annuity. Determine the quarterly payment size rounding to the next whole dollar and construct an amortization schedule. We're going to begin with a time diagram. So in the time diagram, we're going to show that we have quarterly payments over 1 year. So that tells us right away that the number of payments is 4. So we've got a 0, 1, 2, 3, and 4. We have a loan of $20,000. So the loan is going to be placed at the front end of our time diagram or our timeline. So $20,000 loan. We're going to be making quarterly payments over 1 year. We don't know the size of the payment, so we'll use the variable R, or in your case, if you've got a financial calculator, you'll be using PMT. So I'm going to draw an annuity bus around this. We also know that the payments are made at the end of every interest period. We assume that the payments are made at the end of every interest period because we aren't told otherwise. So we have an ordinary simple annuity of n is equal to 4 payments. The interest rate is 10% compounded quarterly. And so what that means is that the interest rate per period is 10% divided by 4 quarters per year, or the interest rate is actually 2.5% per quarter. And so we have a present value of $20,000. So our focal date is going to be at the front end of this annuity or time diagram. So given that information now, we can use the formula for the present value. So the formula for present value states that the $20,000 is equal to R dollars per quarter multiplied by the present value factor, 1 minus 1.025 negative 4 exponent divided by 0.025 and solving this annuity equation. So R will work out to a payment size of $53.16 and 30, if I round that off to the nearest penny, to 36 cents. So the quarterly payment will be $53.16.36 per quarter. And so we'll be making 4 of these payments. However, we were told that we should round that off to the next whole dollar. So what we're going to do is we're going to change the size of the quarterly payment to $53.17. We're going to round to the next whole dollar, not to the nearest dollar, but to the next whole dollar. So therefore, the quarterly payment will need to be reset to $53.17 per quarter. Okay, great. So now we're ready to start thinking about how we're going to construct the amortization schedule. Now, an amortization schedule is simply a table of values that shows you complete details as to how each payment is applied in your loan. So when you borrow money, every time you make a payment to the bank on your loan, you will be paying a portion of your payment towards the interest costs of the loan. That will be taken out first, and then the rest of the payment will be applied to your principal. So with this particular amortization schedule, we know that our payments are $53.17 per quarter and that the interest rate is 2.5% per quarter. I would like you to draw in the amortization schedule or identify the payment numbers, and in this particular case we have 4 payments. So start your schedule with row 0 and go all the way up to 4, recognizing that there will only be payments at the end of every quarterly period. So your first payment of $53.17 will occur at the end of the first quarter. So $5,317 will be made at the end of the first quarter, $53.17 again at the end of the second, and $53.17 again at the end of the third. Now the last payment will have to be adjusted a little bit because remember that we rounded to the next dollar. So we took this quarterly payment as was calculated, and we took it up to the next whole dollar. And so what that means is that the final payment will not need to be as large as $53.17. We call this a balloon payment. Now, at time zero, when we borrowed the money, we obviously did not make a payment, but we do have an outstanding balance of $20,000. That's the amount of our loan. So let's indicate that our outstanding balance at time zero is $20,000. That's our opening balance. And what's going to happen is this balance will be continually reduced with each payment until eventually we have a final balance of zero. So our initial value, or our present value, is $20,000. Our final value is going to be $0 when we're finished paying off this loan. So those are two important pieces of information. Now we're ready to start filling in some of the values. For example, let's figure out the interest portion of our first payment. We've just made our first payment of $53.17, and we'd like to determine how much interest is going to be taken out of that payment. So in order to calculate the interest portion for any payment, what it's going to do is we're going to say it's going to be based on a percentage of the previous balance. And so our percentage is going to be 2.5% of the previous balance. And our previous balance after the first quarterly period has gone by, the previous balance is $20,000. So we need to calculate 2.5% of $20,000, and that works out to an amount of $500 exactly. So with our interest on our first payment, we will be paying $500 to the bank for the interest. What that means is that the principal portion of our payment will be $53.17 less the $500, and $53.17 minus $500 is $48.17. So we subtract the interest portion from the payment to obtain the principal portion. And now we subtract again because $48.17 is reduced from our outstanding balance. That leaves us with a new opening balance of $15,183. So our balance after the first payment has been made is $15,183. Now we make another payment at the end of the second quarterly period of $53.17, but this time around our interest is going to be 2.5% of the $15,000, 2.5% of our previous balance. So let's step aside and calculate that. And so now, in order to calculate the interest portion of the second payment, the interest portion of the second payment, what we need to do is calculate 2.5% of the previous balance. So in other words, we need the balance after the first payment. So we'll have to work out 2.5% of the $15,183. And that works out to an amount of $379.57. And now we can fill that in on our amortization schedule. So for our second payment, only $379.57 will go towards interest. What that means is that a greater portion of our payment will now go towards the principal. In fact, $53.17 minus the $379, subtracting, will give us a value of $49.37.43. So our principal is now reduced by that amount. Now we can deduct that from our previous balance after the end of the first quarter. That will mean $15,000 minus the $4,900, giving us an unpaid balance of $10,245.57. So you can see that our balance is constantly being reduced with each successive payment. Now let's step aside and determine the interest portion of our third payment. So the interest portion of our third payment will be 2.5% of what balance? Well, now it's 2.5% of the balance after the second payment. In other words, the previous balance. So balance after the second period. And that is going to be 2.5% of $10,245. So it'll be 2.5% of $10,245.57, giving us an interest portion of $256 I can put that amount into my spreadsheet or into my amortization schedule, $256.14. So the interest is being reduced with each successive payment. The principal is being increased with each successive payment. When I subtract the 256 from the 5317, I end up with a principal portion of $5,060.86. And now I can deduct that from my previous balance, giving me an unpaid balance of $51.84.71. And so that's my balance after the third quarterly period. Now think about how we're going to construct the last row. What is the information that we know? Well, we know that the balance after the fourth payment has been made has to be reduced to zero. That's pretty important, and that's going to be where I'm going to focus all of my attention. So how do I get that balance down to zero? Well, there's only one way to get it down to zero, and that's if we pay it all off. So if we wish to reduce our previous balance of $51.84 to zero, the only way that I can reduce it to zero is if I pay off $51.84.71. So therefore, I have to reduce it by $51.84.71. I need to pay it all off. And what do I need to do in order to pay that all off? Well, for one thing, I still need to know I need to pay the interest. The bank is going to demand their interest portion, so I need to calculate the interest portion of the fourth payment, and that's going to be 2.5% of the previous balance, the balance after the third payment, and that's going to be 2.5% of 51.84.71, and that 2.5% works out to an amount of $129.62. So now I know that I will need to pay interest of $129.62 to the bank for interest. So now comes the big question being, what's the size of my final payment? Well, with my final payment, I need to pay off the interest, and I also need to pay off the principal of $51.84. So therefore, I need to add these two amounts together to come up with a total. I need to pay the principal and the interest. That gives me a grand total of $53.14.33. So $53.14.33 is the size of my final payment. At this point, I would like to discuss with you the use of your financial calculator if you happen to have one, especially the BA2 Plus. You can use the amortization function on the calculator to give you the same values that we've just calculated in this schedule. For example, if you key in $20,000 for the present value and negative $53.17 for the payment, remember that payments are always the opposite sign of the present value or the future value. So we're going to use positive for the present value and negative for the payment. 10 is the I/Y, or the interest rate per year, 10%. And because it's compounded quarterly, we're going to go second function IY to key in 4 for the number of interest periods per year, and down arrow button, double check to make sure that the payments per year is also set to 4, and go second quit to get out of the interest functions. Now what we're going to do is we're going to key in second amort, press the second amort function, and your calculator will then ask you what periods you wish to enter for. So we're going to say for P1 equal to 1 and P2 equal to 1. Let's take a look at what the output is for row 1. So we want to go from the first payment to the end of the first payment, or cover the first period, and remember to hit the enter button every time you change a P1 value. So press the enter button and then press the down arrow or the cursor down key. And if you keep pressing the cursor down key after row 1 has been entered, you will notice that the calculator actually spits out values for the interest portion, the principal portion, and the outstanding balance in each case. So if you keep going down that set of functions, and now if we change P1 to the second payment, so change this to P1 is equal to 2 and P2 is equal to 2, and if you want to find out what happens at the end of the second period or second payment, then of course you'll have to enter in new values for P1 and P2, press the down arrow key, and then you'll get the outputs for the balance, the principal portion, and the interest portion after the second payment. And again, what I would like you to try is try changing the values from P1 equals 2 to P1 is equal to 3. So let's see what happens at the end of row 3. So P1 equal to 3 and P2 is equal to 3. And so you'll see that your calculator will actually give you all three elements or three values of those important cells in the third row. So it's a very handy tool to have.